Hello, 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 hello. Welcome, welcome, welcome. Hope you're having a wonderful day so far. Welcome back, everybody. My name is Michael. Hope you're having a wonderful day so far. Okay. Well, welcome back in, everybody. Today, it's Friday. Friday, fun day. I don't know. Um, I'm kind of like honestly, I'm kind of like at like a little bit of standstill in terms of like where I want to go next. Like, there's definitely things that we can do. Obviously, we can add more simulators to our already existing SpectroSim page and continue on with that project. But I like to build and kind of move on. I have that kind of tendency to build and dash. And so I'm trying to think, like, what should we get started on next? Like, should I start my idea of the project tracking site? Like, should I start it? I know we wanted to have maybe have that be the hackathon idea or the whackathon, but I don't know. I like building projects. The leak code's fun and all, but and I do learn stuff from the leak code, that's for sure. But I am kind of at like a standstill. I've kind of reached my, I don't know, my initial goals. I don't know. It's kind of hard to describe. If any of you guys can relate to this feeling, like when I first started, I set this goal that I just really wanted to learn Python and like make some projects and see where it took me from there. And I've kind of accomplished the goal. Like, the job is not done, but like that initial goal setting. So I think maybe we need to have like a formal goal setting session. Maybe would be helpful and useful at this stage, where we look in the mirror and say, what do we want to do next? What do we want to accomplish? What do we want to learn? And why do we want to learn it? Because my why I was originally kind of getting into Python is I wanted to like make things like the small business manager and the SpectroSim site, right? So I do have to have like a desire to want to build a project that relates to that subject, to kind of want to kind of get me to put in that or that effort, right? Because I could just go play some guitar now and just kind of hang out, but and we got to keep learning here, and I want to see what's next. Now, obviously, we can keep going in math, but the math is it's just hard, you guys. It's not hard in terms of the math, but it's just hard because I get a lot of like, honestly, with you guys, I get a lot of negativity when I stream the math. So it makes me want to like just want to do it off stream, but then if I do it off stream, then it's just like content that could have been on stream. That's how I view when I do work off stream. I'm like, man, if I would have just streamed, that's an hour of additional content for you guys that like or whatever. So like, I really try my best to just mentally, I try my best to just stream everything I code pretty much, with some small exceptions. But I got like 20 people on my last math session, and like people just kind of just haters. And I wasn't really like used to it, and so it kind of threw me off. So I don't know. I didn't really. It's interesting. Yeah, I had a week of a lot of programming because of Dune Awakening. Oh, Dune Awakening, nice. Is Dune Awakening, is it a game, or is it talking about the movie Dune? Do they make a game of it? I think what I would like to do, though, I think it would be fun for us to react to watch a YouTube video together. It's Friday. I think we've earned some chill, fun time. To now, I guess I've been giving myself a lot of chill, fun time because I took a day off from the stream, right, and I went to a concert. Um, but yeah, it's interesting. Hold on, so. Uh-oh. There's one I wanted to watch. don't know, his videos are really long though. I wanted to watch the PewDiePie one because I thought it looked really interesting. So I was gonna see if we wanted to watch one of his videos together. His most recent ones. Um, these are the most clickbaity title thumbnails though. Brutal. I gotta step my game up. See, I wanted to watch this one with you guys.
Presenting PewDiePie's $1 billion plan. Let's go.
How's it going, bros?
My name is PewDiePie.
Check it out. New camera. What do you guys think? Pristine. This is actually, if you can...
Go again. What? Why is Pewds better engineer than half of it? Is this what retirement looks like? I hope this is what my retirement looks like. Just, I'm gonna go play.
I don't know, we're gonna get hit with copyright though. I don't know how it works. We'll have to see. What do you guys think? Give me some feedback. Alright, let's continue on. Let's code though. Okay. Let's get a warm up going. Damn, are we? I want to, but I don't know if we're gonna get hit with the copyright stuff. YouTube's brutal with the streamers on that. I'm nervous. Okay. Okay, 3005. You are given an array of numbers consisting of only positive integers. Return the total frequency of elements in nums such that those elements will have the maximum frequency. Such that those elements all have the maximum frequency. The frequency of an element is the number of occurrences in the element in the array. So output is 4. The elements 1 and 2 have a frequency of 1 and a frequency of 2, which is the maximum frequency in the array. So the number of elements with the maximum frequency. Okay, so it's a little bit of a twist on counting elements. Interesting. So the number of elements in the array with the maximum frequency. So you just have to find which ones have the maximum frequency. Okay, so you have to just... Okay, interesting. So maximum frequency, right? You just sum together two elements. So if there's a tied maximum frequency between the elements 1 and 2 have a maximum frequency of 2, they appear twice in this nums array, which is the maximum frequency of the array. So the number of elements in the array with the maximum frequency. Okay, so then if you just summed occurrences then of maximum, got you. So we just need to create a frequency map, loop through the keys and values, detecting for our maximum. And then just sum if they're all. Okay. Okay, so let's just say we're going to have a count, right, is equal to a dictionary. We're going to say for num in nums, right? We're going to do count dot get num or 0, and then we'll plus 1, and we'll set this equal to count key of num. Okay, so this will basically just auto increment the count for every number in nums for having the value of the key of num and the value being the count. So now that we have that, but we also have to, while we loop through this, we can detect a maximum, right? So we'll say we'll have to set this, or we'll say if count num greater than max frequency, right? We're going to set, what is that indentation? Why is it doing that? Give me an indent, an actual indent, what the heck? If count index of key of num is greater than the maximum frequency, then we'll set maximum frequency equal to count key of num. Okay, so that will keep a max frequency. So now at the end of this, we're gonna have to do one more pass, right? So we're gonna have to be at my solution right now is at 2n, right? So it is linear, but I'm having to loop through twice 2n. Now we obviously drop the 2, but it's still, for large data sets, it's not too fantastic. But let's put it, okay, so let's say for num and count in, oh no, shoot. We'll have to say num and num count in count. We'll have to say dot values, no dot, sorry, items. I'm going to set a result here equal to 0, and then say right, if num count equal to the max frequency, then we're going to so is there a way actually that we can just keep track of it? So let's say max frequency, let's say occurrences equals to 0 as well. So could I instead, so let's say this, for number in nums, let's go ahead and get the current count of the number within our count dictionary. I'm gonna say counts, right? Because we have multiple counts. And I want to use the count. Okay, so counts. So then we'll say if the number is greater than, if the count, right, is greater than the max frequency, meaning that we need to replace the max frequency. Then we're going to update the max frequency, and then also occur is equal to 1, right? Else, what is this space? Why is that not auto indenting? This is really okay. See, it's like being really. Is that just off? Is that why? I think so. Okay. So we're gonna set the occur to 1. Else, right? So I'm gonna say if so if the if it's less than, we're going to just move on. We just need to update the count. And then if it's equal to, we just need to update if counts index num, right, equal to the max frequency, we're going to increase the occur by 1, and then I'm going to say okay, so else we don't need to do anything. So I'm going to say return occur times max frequency. Now I might have some errors in here, but let's see. Oh yeah, that's what it counts, right? Okay, so I got 6 back in both cases. Okay. Let's see here. So we have counts, we have occur, we got 6 back. Let me print occur and max frequency. Let's see what I got. Okay, I got 3 and 2. So my occurrence is 3 occurrence. Why did I get 3 occurrences? I should only have gotten 2 occurrences. The 2s and the 1s. But I got 3 occurrences. Okay, so let's think. So our occurrences is getting updated 1 too many times. So, oh, so this is evaluating on both conditions here. So I need to say, oh, we reached our follower goal. Hey, thank you for the follows. Appreciate you. Who was that? It followed. It doesn't show me in the chat here. My bad. Can I see? Wish I could see. Is that Lionheart? Is that the only person in here on Twitch? Hey Austin, how's it going? Okay, so I think it's right here. So if, right, that doesn't occur. So when I say elif here, okay, so I still to this day get a little bit confused sometimes on if elif, which is funny. Okay, so the if will always take place. So we will always check. If this hits, this will not check. I think, right, let's test the print. There we go. Now we did it in just one pass. I think that's our answer. Woo! Let's go! Let's turn up the tunes. Haha. We need some like. I'm gonna get copyright, dude, but we need some just like Led Zeppelin or something. I'll have to cut it out of the stream. You need cooling, baby, I'm fooling. Baby, I'm fooling. Oh, well, now you. Well, I gotta turn off the music. We gotta turn off the music. Vibes are, got brought back to reality here by Slogan. Brutal. Brutal timing. That was brutal timing. Okay, I'm going to check my solution here. How does my solution look for 30,005? There's any improvements. Boom. Updating an occurrences on the fly. Consider collections counter. Yeah, right. That'll do it for us. $9.5. Nice. 9.5 from the judge. Yeah, we did hear about that slogan. Yeah, it's crazy, man. There's a lot of crazy stuff going on right now. Planes, missiles. Like, it's just, I don't even know, man. Just feels pretty dark. Feels pretty glim. I think that's why the coding vibes are off. I think, honestly, I think that's why, like, honestly, just the vibes and just the world are just. This is so stupid to say, like, the vibes of the world are off, but it is true. Like, it's just like the energy of the world is out of whack. Just feels very like something's lurking, and I don't know. It's just interesting. Okay, let's get this. Yes. Anyways, let's solve a leak code problem. Anyways, let's solve leak code. Let's solve some leak code. Anyways. Oh my god. Okay, let's see. Do we need to pick another random? I like the random. That was cool. Okay. I had it on easy. You're gonna give me a heart? Given an array of digits which is sorted in non-decreasing order, so in increasing order, you can write numbers using digits I as many times as you want. For example, digits equals 135. You may write numbers such as 13551, 1351315. Return the number of positive integers that can be generated that are less than or equal to the integer n. So the n is n, we have output is 20. The numbers that can be written are this. This sounds like a recursive backtracking problem. We're trying to find all the numbers that can be written under these circumstances with these digits. So you can write them all individually. You can write all the ones, all the threes, all the fives. Okay, I think we can solve maybe our first hard here. Is this not just recursive backtracking? Well, we'll find out. Okay, let's say backtrack. Okay, what do we want to give backtrack? So you can be given digits and a number of an n number up to n. Okay, so what do we want to keep decreasing then? The size of the string. So we want to find all of the single digits, all of the double digits, and all of the triple digits, all of the okay. So gotcha. So the string size was dynamically changing. But we're also keeping a count that we'll have out globally, right? Okay, so let's try it. I don't know. It seems interesting. It doesn't seem too crazy, but am I naive? Okay, let's say this. Well, you have quite a wide range here, though. So n can be very large, so recursive backtracking may not be very efficient because. So do we need to like? Uh-oh. Maybe we shouldn't have started. Three, 9, 27, 81. Oh, there's a pattern. There's a pattern. Okay. So you just have to take the length of digits. Right? So this is your factor. Right? So how would you interpret it then? So you would do this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is n. So the length of so n. I'm gonna convert. I'm gonna say stir length of n. Okay. So that'll give me the length of n itself. Yeah, right. This problem, there's a pattern to this. I think I've solved the pattern. I think I've got it. We'll see. It might be by eating crow here in a second. Okay, so the length is here is 10. So you won't. That's what we need to. Up to, right. This goes 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 passes. Okay, so we say what's this? Let's say for I in range of n, right? We're minus 1. We want to do one less pass than n. we're going to say count equals to 0. We're going to say count multiply equals by the factor on each pass. And now we're going to return the count here. Am I crazy? Oh, sorry, length stir, my bad. Oh. Okay, so it starts at 0. So we have to start at 1, sorry. So we know our count is going to initially start at, I think, at factor. This goes 4 times, so this is our length is 4, which is our factor. So factor times the current count, which is 4. So this has to equal factor at the start. There you go. I think that's it. Come on, baby. Show me my first heart. No! Come on. Pause on that. That was a big pause. Okay. So we need to say, this says we initially have count is equal to 4 at the start. So do I need to go minus 2? I'm not using I here at all, right? So 29,000 times 3, 29,000. Okay, so we'll say, how about this? While count is less than n, well then length stir count less than n. No. So we'll do it 9 times. I feel like we're right there. Okay, hold on. I'm right there. Okay, so we just need to work out the math here. So on this example, 3, which is our initial count, 1, 2, 3. I think, is it multiplied by 2? Don't want me to start, minus 2. 16. Oh, so it's going to be plus 90. This. Sorry, my bad. Count plus equals count times factor. Come on. No! I feel like I was it. Am I going way overboard? I didn't mean to submit there. Okay, we got that one. We're short on this one. Okay, I think our math's slightly off again. Okay, so this one we got test 19. 196,000. We need 20. So I got this number. So I needed to do one more pass, but I thought one more pass was too far. So count initially equals factor, which is the length of the digit, so it equals 3. On the first pass, no, we're right there. On this one, right, we get the 19,683. Or no, sorry, on the other one. This goes one too far. So on count, multiply equals factor on the -1. So count though, do we want it to equal, starts off at 1. Starts off at 1. Return count. So if we say it's equal to 1, right? Count is going to be multiply 1 times factor, in this case, which is 3 on the first pass. Which now count becomes 3. Now it becomes 9. Now it becomes 27. Now it becomes 81. Now it becomes here. Now it becomes here. Now it becomes here. In total, these sums together gives you 29,000. So then let's just go like this. Let's just create count multiplied by factor. It updates every single time. Total is equal to 0. Let me say total plus equals count and return total here. I think that might be it. Show me the money. Oh. Okay, so on this, if n equals 8, okay, so we need to return total. So this on the loop, it multiplied it by, so on this one it outputted 0. So the length is 1. This is range of 0. So we'll have to say here, we'll have to have an edge case. We'll say if factor is 1, right? If factor is 1, you can only make one digit, return 1. Hmm. Okay, so we if number, we need to have a check here and say, so we'll say for I. We don't want to go 8 times. We want to go. We want to go. So we need to check here and say if digit if the digits, so the digits is the array and is the amount of the cap, right? And is the cap we can make. So I'm going to put a check in here and say if the, I'm kind of a little bit lost. Okay, so we're in our loop here, looping over one less than the length of the n. I don't know, Marty, hey, how's it going, dude? Welcome back in. This is my first hard I've ever attempted here. But I don't know. Well, I'm trying it here. I've gotten the test cases solved, but I haven't gotten the submission solved. There's some edge cases that I need to figure out. Okay, so if the digit that we're currently on so we don't want to return one though, so because this goes by if it's n, which is the length of here in that example of here length of 1. Right, so if it's a length of 1, it's just a single number, and that number is 7 that we can make. If that number, if digits, so we have to have this here. Okay. So then what I can do, I need to evaluate, because if the digits on each pass, the count goes up. So I'm going to say I here, right? So I is the pass count. So I is the pass count, and if we want to track if stirred length I, if length of stir I is, okay, say this, if length of stir I, if the length of stir I, right, is, so we wanted to track the magnitude basically, right? So if the length of stir I becomes greater, no, so if the length of I, so the loop count, no, I will be 0, 1, 2, 3. So no, I is not the magnitude. Let's check what we want to do. Yeah, so 0, 1. So I'm going to say 1 to actually just end then. And so I'll say I, so 1. We're not going to do this then. We're going to say if I times the, if I times the current number that we're on, so I is going to be the loop count. So at first it's going to be 1, which is the magnitude of numbers that we're looking at, single digit numbers. On the second pass, we'll be doing 2-digit numbers. So if but I'm not actually looping through digits individually and tracking digits, right? If I is less than our factor, so if I is less than our factor, we can track digits here. Right? We can track digits if I is less than our factor. So as long as so our factor here is 4, and I will be 1, 2, 3, 4. Well, that means I have to start. So it's I less than 1. If that's less than factor, we can track digits individually. So if I go into num's index of I minus 1 on the first pass and get the 1, and I'll detect if this number is less than n, go forward. If it's not, we're going to return right away. I don't know. This might not be super. So factor and digits index of I less than 1 greater than n, return, because we're not actually making the well, the maximum 2, so the maximum So we'll multiply this actually by the maximum we can make at this point in time is 77 or 55 or 777 or 55. So the maximum number you can make on each digit magnitude is 7 or 17 or 77 or 777. So it's just I times 10. So if digits I less than 1 times maybe I need to have an inner loop here actually doing this evaluation over each digit. But the maximum actually is this, so let's like walk through this. So like it's gonna go to this on index of 0 here. I'm starting to get a little bit lost here. On the first pass, all right, we don't want to do 29,000 recursive steps. So I need to, there's a pattern here that I established. I figured out that pattern. Now I'm trying to do some edge cases to detect if the actual digit that we've created Oklahoma, one on the road. Hey Wolfie, how's it going, dude? Welcome back in. That's rough. Sure, Indiana fans are triggered. A lot of people have been betting on them. Probably you too, Tim. So, how can I... Okay, this is interesting. Okay, this is what I have so far. Right, this is able to pass these 3 test cases, hopefully. No, hold on. Right, but this does not pass this, where you have to evaluate the number itself against n to detect if that is a valid number. But the thing is, in my algorithm here, I'm not creating the numbers actually like in an exhaustive backtracking algorithm where I would be actually generating all these numbers and then taking account of the list, right? I'm not doing that here because I don't want to have to generate 29,000 numbers, right? That's a lot of steps. It's a lot of recursions. So instead, I found this trick within this kind of examples that if you have a factor of which is the length of your digit, so in this case 4, if you multiply that by the amount of the length of your n minus 1 by looping each time on factor and then summing that together, like sum for all the times the factor multiplies against uh, your initial count, then it gives you this value you're looking for, right? But there's some edge cases where if you come across a number that's generated, so let me say this. If we ever get to a number, so if let's say this, if we need to track numbers that are equal to the same length of n. So if n, no, so if in this case I is equal to n, right, what we're going to do here is check for digit in digits, no, we're gonna go like this. The maximum number you can make is the last number multiplied by 10. So, and digits int digits index of -1 times 10. No, in this case it would be times I, right? No, that's plus 10. That's plus 100. No. 7 plus 10. That's just plus 10. 7 plus 7 times 10. Okay, so that it's 7 plus no, I'm not sure, Wolfie. I'm just trying to women it. I just selected at random shuffle a problem on the easy screen and it gave me this one. So it's just fate. um so right, I'm going to take the integer I'm currently on, which is, let's say, 7 in this case. I need to multiply this by I, which in this case is 3. No, I minus 1. I minus 1. So that would be 2 times. I get from 717 to 77. I added 10 there, and then I added 1, and then there I added 2 times 70. 70 plus 10 times 1. 70 plus 10 times 7. 70 plus 10 times 7. So this would be digits index -1. 7. God. Digits index of -1 would be the -7, would be the 7. Now, the maximum number we can make at that pass is I minus 2, which is, let's say, because we're checking if I is equal to n, so n is 3, so I would be 2. I is 2, and we're going to multiply that by 2 times. I don't think we're going to do anything with that, actually, because we need to multiply. Everything goes up by 10 in the first pass, and then in this next pass goes up by 10 times. 10 times 7 is 70 plus 7. 10 times... So what would it be on the next pass? Well, I don't have that ability. Ten times that number plus that number. But on the 17, I just added 10. And then the next pass, I added 70. This one is 902. Okay, so if I is equal to n, we need to evaluate these numbers. Well, I would never be equal to n. Actually. We go up to n. So we're trying to evaluate this. So where if I, in this pass, we're only going to go over n is the length of this, and which, so n is equal to 4 here. Okay. Which, so the length of this is 1. So if let me see, this is m actually here. Alright, I want to overwrite n. So let me say length of stir n is equal to m here. So m is going to be equal to 1. N is equal to 4. So if the, so here I'll say if I'm not sure. This for loop is not too slow. This for loop is pretty fast. I'm going over magnitude, so I'm going over only 9 passes here. Right, 9 loops, not 29,000 loops or a million or whatever, how many zeros this is. I'm only doing 9. Right, I kind of figured out this little hack, but I have some edge cases that I'm missing here. For instance, when the digit that I created, so in this case, I can only create length of 1 digits, right? So say if m so this is saying this is going starting on 1 and would end on 1, so this wouldn't even enter into that. So I have to say if m is equal to 1 here, then what do we want to do? If m is equal to 1, then we need to say for digit, I'm going to put my total up here. Hey, follow. Goal started 150. Like, it'll scare me a little bit. Okay. For digit in digits, right? If digit less than um, n, we're going to total plus equal 1. So we have int digit. Okay, so we hit that edge case. Oh, another edge case. All right, so n is 4. Oh, less than or equal to. So it can be equal to n. So if we use this edge case, okay, we pass that guy now. We're just running submits like crazy here. Okay, now we have another edge case here. So I did one pass to n. So I'm not doing the n pass in here, so I need to go like this: 0, -1. And now no. I could go to 0 to n -1. That's fine, but right, this is the part that kind of solves the generic stuff. Right. So then we, in this case, 59, I only outputted 3 when I expected 6. 5, 7, and 8. 5 and 7. Which is less than 59. So the thing is I need to be making the digits, but 5 and 8, which is less than 59, but 7. Those ones are not. So then 5. What if I just take the first one of the string and the last one of the string of the list, multiply, concatenate those together? Okay, let's do that. Let's take so where on the pass, okay, so let's do this. So on the pass where I is equal to the length of n, so m, which it won't ever do that. So stop 2 prior. Right, this still works, right? For those test cases. Yes. Okay, so if I say if I in this case is going to be equal to which it won't ever be. So how can I build? See, in this first loop, I'm only getting 5, 7, and 8 and returning that. But if I go, if I is equal to m less than 2, right? So on the last pass, what we're going to do is go and say for this here, I think. And then what we're going to do is break at the end of this loop and return total. I'll hold up. Else. Let's try that. For every digit, we're going to no, we don't want to increase it by 1. We want to detect if this digit so do I want to recursively backtrack on this now and make this single row? So do the algorithm part and then recursively backtrack on just when you hit the part where you need to evaluate the individual when you're making numbers that are equal in length to n. and evaluate each one of those. I think that would be it. So rather than doing this, let's say this. So if I is less than 2, then we're going to call backtrack on no. So if put given n, we're going to evaluate every number combination. Okay, so I'll say given. I want to backtrack on this. So what is my? I just want to do one occurrence. String, right? And I say, okay, so now I need to find this. So I'll say given, we want to give it, what do we want to give here? Right. So if string come on. Got a sticky cap locks key. Come on, get out of there. Okay, so I'm gonna say for digits in digit, we're gonna call backtrack. So for digit in digits, we backtrack on the digit. We want to concatenate it to string is not equal to n. How did I do that one from yesterday? I'm just gonna go back up here and look at my notes from yesterday. That's not what I wanted to do. I want to look at my notes from yesterday's when I was working on the here. Yeah, I think so. Okay, here's okay. What we call backtrack on string plus digit here. Okay, if int string less than n count plus equals no matter what we're going to return. Okay. So I call backtrack on the string. That'll increase the count. Sorry, this should say total. And then we're going to, this is already on the last iteration. M I equals n. So on the last iteration, I backtrack. And that's how I increase total. Sorry, I'm missing out on the chats, you guys. My bad. Hey, Keeler, how's it going? Abith, how's it going? Okay, so we have, I call backtrack. Why does this not work? So let me print total under repass. So this didn't even print anything. That's stuck in here. So so on this test case, so I on the first pass, if I is equal to, I is equal to 0 at the start. So we want to say 1 up to m minus up to m no, so this will go from 1 if I is equal to m minus succeeded. Oh boy, guys, we get ourselves into here. Okay. So this is I starting off at 1. It's going up to, in this case, not 3, up to.
Tim says we got ourselves into a street fight.
So if we go up, this is only going to loop once. And m minus, so in this case, m is 3. M minus 2 is 1. So this is immediately calling backtrack on this. Return backtrack. Check my, on that other one. Just call helper. Return. So I just call backtrack upstream plus digit. It grabs the 5, 7, and 8 up into the string. Applies a 55. Okay, that string is equal to the string length of the string. Right, if the length of the string is equal to so if the length of the string, right, in this case would be 55 or 57 or 58, which is 2 in length, is equal to the length of the stir of n, which is 59, so this is 2. We're going to evaluate if that int on that string, 55, is, and then okay. I want to loop 1, 2. So if this is this is 4 m minus, which is
says best viewers on Boost
no. So if this is length of 4, no, this is m. Length of 3 minus 1 would be 2. We're only looping once over this. Okay, so that's not correct. We need to be looping twice over this, right? So we can make up numbers that are double digits. And then if we get to a point, if we get to the last iteration, then we backtrack. For 9840. supposed to be 1, 2. That's supposed to change here, so maybe getting into here. 1, 2, 3, m. In this case, m is 1, so it's not even entering. We have to enter into this loop. Right, we have to enter this loop. Well, hold on. So backtrack. Got 0 back. Because it's not even entering the loop, because this is a length of 1. We're starting at 1. Let's go 0 up to 0. So it will have to say if
Xeon says, Ayo, it's been 10 months since you started learning Python?
yeah, kind of about a year, yeah. A little bit longer than 10 months. Okay, so if we have okay, I think about this. So if we have okay, so if we have, this is called backtrack. Okay, I'm gonna give it this backtrack. I'm gonna say, how does this look?
Darson says, say hi.
How's it going, dude?
Darson says, hey.
Yeah. So this is backtracking. So then the thing is if the factor is equal to 1, the length or digits, we have one number in here. So if m is equal to 1, right? Then we're going to call backtrack here. Okay, yeah, maybe I can just sacrifice space for the last few successful ones. Just make them like digits 9. Okay, so let's do this. I have total here. Let me call finals is equal to an array here. Put that Huh. How did I do that last time then? What?
Wasalo says, how many lead code problems have you solved?
2.
Darson says, oh, that's error. John says, reading is for dummies.
we So we backtrack. We turn count total. See here. We can call here count. Oh shoot. on. So many bugs. Mike, come on. Nine 840. Ah. Okay, I'm gonna go like this. We've been working on this one for a while. I am working on a failed attempt at the code 902. Do not show me code. I am trying to challenge. Am I? Oh my gosh. Am I even in the right ballpark? I figured out a hack to loop over 2 less than length of Esther and summing the factored total. I solved the main issues, but have edge cases where the
Darson says def at most n given digit set d n s equals str n uk equals len s d equals less mat str d count numbers
got a
with
smart
fewer
guy over
digits,
here.
total equals 0 for I in range 1 k total
So
plus
frustrating.
equals len d I.
Alright, TTS is off now. Lost your privilege. Where the number, the digit is the, or the loop duration is the one prior to the length of str and where I want to backtrack to find all counts of valid numbers. Here's my current. Dude, I said no code. Dude. Why are you showing me? You can stay on the right track. Counting all numbers shorter than n using combinations of your digit set is exactly what you should be doing. You're handling that part. You're absolutely right. My bad for the beginning. Numbers shorter than n. From what you described, the problem seems to be the edge. The number you're building is the same number of digits as n. You want to make sure you're less equal to it. This is not something you can brute force without trimming bad paths early. That's right. When you're backtracking to build numbers evenly. When you're backtracking to build numbers of equal length to n, think about this. As you build each digit, once you finish refining how to handle full length numbers and trim invalid ones, you're there. Okay, so I'm gonna say what part of my I'm gonna say what part should I be focusing on? The current. Give question a huge props for your other challenge asking. Counting numbers with 0 digits and end. Separate logic for full length numbers m digits. Using backtracking for edge counting, good instinct. The subcount function. This is where you're trying to backtrack through all combinations that are same length as n, but your total counter inside your function isn't updating because it's not scoped correctly, since you're using a nested function with a primitive int variable total equals 0, total equals. Alright, well, we'll try this one again later. That's all the time I'm going to give it. That's all the energy I'm going to give that one. Alright, I think I'm done for tonight, though. Oh, I'm getting tired of the leak code, guys. I need to get a project going. This is not that fun. I'm going to be real with y'all. I mean, we're solving problems, like learning stuff, getting practice, but this just is not fun. Like, we got to be building projects. I gotta, shift focus here. So I think I'm gonna start building my idea. I know we're gonna. I think I'm gonna start building it, and if you guys would like, so for the wackathon, if you guys would like to build it with me, that's completely up to you guys. I'm gonna open it up for that. But I definitely am more project oriented. I'm just bored sitting here doing these leak code problems. They just do not make me want to come and sit down. Well, we've already built some projects here. This is our most recent project we just pushed a couple days ago, SpectroSim, where you can access spectroscopy, absorption spectroscopy of various compounds. So there is a spin down period on the host render.com. So you do have to wait about 30 seconds for the first query of like if it's not been hot for a little while. It's got to spin up. So the first query does take a little bit. I added this feature so it does, and then I think I'm going to add a little bit like a note below here that says um, server host has a spin down period. Please allow 30 at least 30 seconds for first search of you know or something like that. I need to figure out some sort of kind of warning phrase to let them know, hey, like if this is the first search in a while, it's going to take a little bit because render.com is kind of buns that way. Oh, it's really a long time, render.com. Come on, dude. That's a brutal spin down period. It's like 50 seconds. Oh, come on. There we go. That is so brutal. And then you can generate plots, right? Which is really cool. And you can download them. So we've already built this with React, Tailwind, Python, Fast API, JavaScript. We can look up like benzoic acid. See, now it's fast because it's already hot now. The server's hot. It's awake. We had to wake up the server, which is really annoying. And we can do like salicylic acid. Generate that one. You can do like caffeine. Generate that guy. So pretty cool. Like we've got some good projects here. I was just kind of doing some leak code practice just to help do that interview prep in case we want to start making that jump, you guys. But honestly, just the leak code is just so boring, man. Like it's just so boring. Like yeah, it's fun challenging myself and solving things, but is it daily? You're given an integer number. You know that Bob will sneakily remap one of 10 possible digits, 0 to 9, to another digit. Return the difference between the maximum and minimum values Bob can make by remapping exactly one digit in number. Note, when Bob remaps a digit D1 to another digit D2, Bob replaces all occurrences of D1 in number with D2. Bob can remap a digit to itself, in which case the number does not change. Bob can remap different digits for obtaining minimum and maximum values respectively. The resulting number of remapping can contain leading zeros. If you are given an integer and then Bob is going to remap one of the numbers in my integer. All of the occurrences, okay? Return the difference between the maximum and minimum values Bob can make by remapping exactly one digit in number. Okay, so this is 1. To achieve the maximum value, Bob can remap the digit 1 to 9 and yield 99899. To achieve the minimum value, Bob can remap the digit 1 to 0. Oh boy. Okay. I'm kind of get it. So what it's asking is that you have a number. He's gonna rechange all the values of one of them, so all the ones to nines to get this, or to get this, and then he changes all the ones to zeros to get this, and then takes the difference between those and gets this. So if we go, let's go like this. Let's say, so if we come across a 1, so we need to set a range, right? If it's greater than 5, if 5 are equal, we want to increase it to 9. And if it's 5 or if it's less than 5, we decrease it to 4. We decrease it. So you need to know the minimum and maximum. No, but the minimum value of any number, like if I take my whiteboard here, I have a number like 2, 3, 4, right? If I want to minimize this by selecting one number, maximizing it, I would just make this the 9, right? Make that a 9. 9, 3, 4 is the maximum number I can make by swapping one number with 0 through 9. The minimum number I can make is swapping this with a 0. Now it's just 34. So we just need to detect what the first character is. So first, so I'll say string is equal to stir of num. I'm going to say string index of 0. This is going to be equal to the first, is equal to first. Okay, and so then I need to just set so I'll say for num in for number okay, for I in string, we're going to int string index of I. We'll say if string index of I, no, for char in string, if char so if char is equal to first, right, then what we're going to do is So what if I set the numbers to 0, pre-compute with the current value against the magnitude, so 9, 90, 900, 9,000. So let me say that, let's go like this. Let's go sub is equal to 0. Let me go, if char is equal to first, then I'm going to go, I'm going to say for I in range length of string, if string index I is equal to first, then what we're going to do is take the magnitude, which is I. I is going to start from 1, though, and go up to n plus 1, right? Yeah, we want to include no, let's go start it. You stay at 0 length I. So we're going to say, if it's equal to it, we're going to say magnitude is equal to I plus 1. We're going to say that sub is going to be equal to magnitude times string or int string index of I, right? We'll increase sub by that. And then what we'll do, but we need to set this value. So okay, so then oh shoot, this might not work. Because if 0 is replaced by 9, man. Return 99. Right, so I'm extracting out here. Okay, 9. I'm gonna try to find every 9 value in here. No, I can't do that. There is no. It's already maxed out at 9. Find the next value. Oh, interesting. Right, so this probably won't work because what I'm trying here is that I was accessing the first digit, seeing if that is that if it's 9. So we have to first find a digit that's not 9. This would be 10. 31 plus 90 plus 800. Huh. Not quite sure. All right, you guys. I think that's gonna be it for me. I've got to wake up early tomorrow. I'm headed out to the lake to visit my family, who's currently, doing some camping over there. Just gonna spend the day with them and hang out. So if I can't come on stream tomorrow, I do apologize. I will let you guys know in the Discord or with an announcement on the YouTube if I'm available to stream. I will try my best to get a session in somehow or some way. But I appreciate you guys bearing with me. We just did some leak code. I'm practicing leak code problems because I think I'm gonna start, maybe applying for some jobs in this space and as a developer or whatnot, given our current projects and whatnot. But these legal problems can be tricky. I appreciate you guys being here and hanging out with me, and I'll see you guys tomorrow. Please join my Discord and chat with me. Please have a great night. Yeah, I'm going to sleep. I'll see you tomorrow, guys. Have a great one. Bye.